for this one, number 3, we're trying to find the maximum acceleration. So whenever we're trying to find the maximum of something, we have to take its derivative, find out when the derivative of that is 0. So we want to know when the derivative of acceleration is 0, because that's when we might be changing from increasing acceleration to decreasing acceleration. So that would give us a maximum. Plus we have an interval here. So whenever this is the case, we always want to check the endpoints. But first, let's go ahead and find acceleration. By taking the derivative, we get 3t squared minus 6t plus 12. But again, we need to know the derivative of that if we want to find the maximum acceleration. So the derivative of that is 6t minus 6. We want to know when that's 0. So that happens when t is 1. Now we don't want to make the assumption that that's the maximum. That just tells us that the derivative is 0. Could have a maximum there, could have a minimum, could be neither. Could be an inflection point. So what we need to do is look at the number line. So when t is 1, the derivative of the acceleration is 0. If we put in a value less than 1, like 0, into this equation, we get a negative value out. Put something bigger than 1, like 2, we get a positive value out. So actually what this is telling us is that when t is 1, we have a minimum, but we're trying to find the maximum. But remember, we're finding the maximum in this interval, so that means we should check the acceleration at 0, 1, and 3. So if we put 0 into the equation for acceleration, we get a value of 12. If we put 1 in there, 3 times 1 squared is 3, minus 6 times 1 is 6, so negative 3 plus 12 is 9. Put 3 in there, 3 squared is 9, times 3 is 27, minus 18. 9 plus 12 is 21. So our maximum acceleration on that interval is actually when t equals 3. It's 21. So, I've said it before, it's important to check those endpoints when we have a set up interval where it's a closed interval. It could be 0 or 3.